Welcome to the Design Co-pilot. This demo focuses on identifying similar parts within a parts library for aerospace and defense engineers to build quality assemblies faster. The Design Co-pilot works by utilizing a custom-built algorithm that analyzes various characteristics such as step file instructions, surface shape identification, and volume to source necessary parts. The part consists of two sections: the part manufacturer expert chatbot and the model viewer. On the left, the part manufacturer expert chatbot allows you to query your parts library using natural language. On the right, the model viewer allows you to view and manipulate parts in an assembly using step files, which is a common CAD file type. Using the left panel chatbot, I can conduct a general search. For example, I might inquire, do we have any parts like a nut with an M10 thread? The chatbot returns three parts that can serve as alternatives in my assembly file. The first part has an M10 thread with two different certifications. It's made of stainless steel. The second part features an M12 thread and one certification, and it's made of ABS. The third and last part is a molded clamp with an M8 thread and one certification, and it's also made of ABS. Another great search feature we have is we can find parts with specific requirement, such as certifications. For example, I'll enter, what parts do I have that match the cert ISO 7045? The chatbot returns two parts with that specific certification: a panhead Phillips screw and a Philister head Phillips screw. There are only two parts in our library with this certification, so the third inquiry has no return. One of the most useful features of this chatbot is its ability to source replacement parts. Let's try an example. What parts can I use as a replacement for SF003? SF003 is a screw with a panhead Phillips and a thread of 256, measuring a quarter inch in length. Our chatbot suggests the first alternative, a panhead flat screw with the same thread of 256, measuring a quarter inch with a similarity score of 91%, while the second and third option has the same thread size, however, they're half an inch in length. Therefore, I would need to inspect the second and third screw to ensure they fit properly in my assembly. In the model viewer, I can physically replace parts within our assembly. This area of the tool allows me to analyze step file data while displaying individual parts that make up that assembly. Each part is illustrated as a different color. Here, I have loaded a hydraulic motor in the viewer. Several REST APIs were developed to enable users to manipulate each part within the assembly. I can hide or show parts, which enables me to click on a part and change its visibility. I can also view the wireframe of a part by clicking S. I can click A, which hides or shows the three axes. The S key allows me to search my parts library for alternative parts utilizing the similarity algorithm. C allows me to convert the part into a force matrix, enabling the algorithm to compare parts and find similarities. Now I'll click on the bolt to search the parts library for an alternative part. Here we can see the Phillips head bolt is 99% similar to the bolt I'm going to replace. Now I'll enter the name of that part, Phillips head bolt, into our input field to load that new part into our assembly. Now that we've loaded the new alternative part into our assembly, I can actually move our alternative part to configure it correctly to fit properly in our assembly file. As we can see, the only difference between the original bolt we had and this alternative bolt is the head. The original bolt had a hex head, and this alternative part has a Phillips head. Next, I will replace the roller, which facilitates shaft rotation. Using the same process, I'll click on the roller, press S, and search our parts library. Here, we can see our alternative roller has a similarity score of 71%. So let's copy the name of the alternative part and enter it into our assembly file. Now that we have our alternative roller loaded in the assembly file, you'll see the difference between our alternative and the original roller. The only difference here is the alternative has a hole going straight through the middle. Now I'll find an alternative for the backplate using the same process. We can see that our alternative backplate has a similarity score of 64%. Essentially, it's the same part, but the original backplate had a quarter cutout, and this alternative is a complete plate. This shows the versatility of the design copilot, that we can find parts that's the same shape, however, they might have more material and a bigger volume. With that, I've reached the end of the design copilot demo. Thanks for listening.